The latest Google Pixel supports AirDrop on Android. Let's debunk some myths about how Google did this and look into its actual implementation. Google didn't say much about how they did this, except from a lengthy blog post that claims that the implementation was written in Rust, making it highly secure. The most prominent assumption was that because the European Commission asked Apple to implement Wi-Fi Aware by iOS 19, the sudden AirDrop support on the Pixel must have to do with this change. But this time-wise correlation doesn't mean causation. AirDrop is based on AWDL, the Apple Wireless Direct Link Protocol. AWDL is highly integrated into the Apple ecosystem, and any migration away from this would break compatibility with older devices, with many more services affected than AirDrop. There's a Pentest report on an early version of Google's AirDrop implementation. In this report, they claim that they tested Google's implementation with Apple devices as well as OpenDrop. OpenDrop is an open-source reimplementation of AirDrop. On the lower layers, it uses Open Wireless Link, a reimplementation of AWDL. As the only finding, this report claims that logging exposes private information. In this Rebus log, we can see that an OpenDrop client sends something to the Pixel using an AWDL 0 interface. The Pixel then receives this on the Muse 0 interface. As OpenDrop only implements AWDL, not Wi-Fi Aware, this means that Google actually brought AWDL to their Pixel phones. This also explains why only the latest Google Pixel is supported, as this requires specific hardware capabilities exposed by the Wi-Fi drivers. How does AirDrop even work? Devices first discover each other over Bluetooth Low Energy and then synchronize over AWDL. Then the sender runs an MDNS service discovery to find where the AirDrop service is. Once the finder found the service, they connect to the receiver with TLS. Here we have three phases. First, the sender posts a discovery request over HTTP to get more information about the receiver device. That's how the sender gets a list of receivers with names to select from. Then the sender posts an ask request. This shows a preview of the file to be sent. Then the receiver can accept or decline the file. If they accept, the sender can then upload the file to the receiver. Let's take a closer look at Google's implementation to see if we can find all these elements. First, let's capture logs. Here, Marius was so kind to borrow me his Pixel for this experiment, where I airdropped an image from an iPhone to the Pixel. The logging became less verbose, but it contains still essential information. We can see the service discovery over MDNS and also the bring up of a Muse daemon that sets up Wi-Fi channel 44. Later on, we can see an AirDrop ask request for an image. Similar information is also visible on the iOS side. We can see that the phone app is used to initiate sharing over AirDrop. Later on, the kernel logs a lot of information about the AWDL interface, including its channel sequence. These logs confirm what we have seen in the Pentest report, but the big question remaining is, where did Google get this implementation from? Did they build their own? So, Open Wireless Link and OpenDrop are not written in Rust, but Simon has an implementation of AWDL written in Rust. One core part of the implementation is inside of the Muse app. Since this is a release build, code shrinking was automatically applied in the build process, leaving us with shortened class and method names. But there is no other obfuscation, so we can start renaming based on strings. After a bit of manual work, we can find the whole upper layer implementation of AirDrop inside this app. An HTTP server, TLS, and a discover, ask, and upload requests. However, there are no traces of the Muse 0 interface. Given that this requires some lower-level support, let's look into the firmware for the Google Pixel 10. Let's unpack the factory image and then the main image included in it. Inside of this, there are multiple partitions. We are looking for a vendor-specific implementation, so let's unpack the vendor partition. Looking for any file containing Muse in its name, there are 4 matches. Muse RC defines how to start the Muse server. Manifest Muse defines a binder service. The Muse server mostly implements this binder interface. Furthermore, we can see that it loads the libmuse daemon FFISO library. This library is stripped and written in Rust. This means that even the strings in it became a mess, as they are not null-terminated. Some strings sound like a lower layer AWDL implementation. To confirm this, let's look at Simon's implementation of an AWDL frame parser. Here, he describes multiple frame types, such as election parameters. Searching for these, we find more strings that are all AWDL frame types. This looks like Google implemented their own AirDrop and AWDL implementation written in Kotlin and Rust, and this is not in any way related to Wi-Fi Aware.